Last time on Call the Pumpkin Map.
This ain't Dragon Ball Z. Tell it like a normal person.
Anyway, in last week's video, link in the description, I attempted to make the electronic guts of a mechanism which would be able to project a pumpkin-shaped light that moves along my wall. There's really only one problem left over from last week, and that's the fact that the motor's speed does not vary like I want it to. Instead of having a gradual speed increase the more you turn the knob, it's basically turned off the entire time until you crank it all the way up, and then all of a sudden it jumps to life at 100% speed. So in order to help mitigate this problem, I've attempted to remove a wire from the entire system. So here's my logic for doing so. I have here a mock-up of the potentiometer itself and the motor. If we turn the potentiometer to the right, all of the electrons flow from the power source through the motor, making it go fast. If we turn it all the way to the left, they definitely prefer just this wire here and they don't go through the motor. But what happens if I just cut this wire? Boom! All of those electrons still have to flow somewhere and they still have to go through the motor. They just don't have a choice to escape through the other side. You turn it all the way up and bada bing, bada boom, they can freely power the motor. So my thought process was, if there's a wire on the other side, it always has the option of going to that wire and it can always pull power away from the motor. So now that this is cut, the power has to always go through the motor. You can see with the wire right here, the electrons are like, heck yeah, I'm going to ignore the motor for the most part and jump through this free path here. But if I delete it, now they have to go through the motor. You can see right here, the current doesn't actually seem to be flowing any faster through the motor, even with me deleting this wire, but it was my last ditch attempt. But while that didn't break it, I do not believe it actually fixed it. You can see here, like, I can get it to run more slowly, but it's so finicky, it's not really practical. I think the real problem here is either that the potentiometer is too strong, so even turning it a little bit will crank up the resistance so high that it's not sufficient power to actually power the motor, or the motor is not made to be dimmable so that even a little bit of drop in current causes it to stop completely. Both of which are things that I can't solve unless I just get a better part. The other problem I had to solve this week, of course, is that this is not the final project. I mean, sure, it has a dimmable motor, it has a controllable light, it's got a switch, it's got everything that I would need electronically, but even if you turn it on, there ain't no pumpkin moving across my wall. So I'm going to need some sort of mechanism that can hold all the switches and motors and all that jazz, and can turn a light into a moving pumpkin shape. And to do that, we're going to have to fire up Fusion 360. And here it is. Essentially, it's a box that holds all of the electronics, and on top of the box sits a globe with a gear on it. And this gear is going to be turned by the motor, and it turns the globe, which rotates around the light, which causes the illusion of a moving pumpkin image on the wall. Ironically, by far the most difficult part of making this thing was putting the pumpkin holes in the sphere. In Fusion 360, there is actually no native easy way to map a sketch onto a round object like a sphere. So instead of doing that, as you can see here, I instead just kind of made a sketch in front of a section of the sphere and then duplicated that around 8 times to make the whole sphere. And now that that's done, time to export that and 3D print it. If you want more information on how a 3D printer works, I'll include that video in the description as well. But it's time to see how long this thing is gonna... My deadline is approaching. I do not have time for this. Okay, so I got the 3D printer going. It is currently 8:21 p.m. on a Wednesday, and it said a whole day and 19 hours, which means that it should be done by the end of the workday Friday. Okay, so here is the semi-finished product. I have no idea why the motor hole was so big. I looked back at my notes and I had the measurements written correctly in there, so I don't know why I just wrote a different number, but you know, I'll fix it later, I guess. Here we have the potentiometer switch, which can drive the speed of the motor. Right here is what happens when you do your measurements and put them in correctly. Look at that. Oh my God, comes in and out so smooth. And this, if you'll notice, there's a big old hole. And that's because I forgot to put this one on the print bed, so I'll have to print that later. But we have the switch here, which fits in nicely, and then there's a little divot in here where the wire will come out of. I've also printed 2 stands, one to position the light at the bottom of the globe and one to position it dead center, so I can see which one looks better. Managed to break the pieces open when I was trying to put this goddamn thing on, so life hack for all y'all out there. Super glue is bonded immediately, instantly, by baking soda. So if you put a really concentrated solution of baking soda on super glue, it'll seal instantly. So the idea is, if I can get this thing set up correctly, is you turn it on, grab the remote, turn the light on to whatever it is you want, turn the switch, that turns the motor on. I'll be printing a gear head for the motor. It'll mesh with this gear, spin the thing around, and then the light will be projected in whatever shape the globe is. Now, I just need to make the globe. And I wonder how long that will take. Okay, I negotiated down with Kira and it says 20 hours, so, 3 p.m. tomorrow, and we should be in the clear. Okay, so, pardon the mess, but I've got the globe here. Like, look at this frickin' tree support that I did. I tried to spare so much time that it just didn't work at all, and I honestly should have just tried not to support anything because it didn't do literally anything, but gotta clean this up and then hook it up. Okie dokie. This is test number 1. The only problem I see with it, it's not shining through the bottom holes, so I wonder if the lower one is indeed the way to go. Okay, test number 2. Ooh, I think that might be better. I think the low one might be better. I might have to review the footage, but oh my god. Look at the ceiling. Isn't that sick? Oh my god. That's so cool. Okay, let's see if I can't explain why I think I should use this one over this one by manhandling the camera here. So I've got 2 stands, one of which is really short, one of which is tall. Now, the point of the tall one is, if you imagine like this, you are currently in the exact center of the globe. However, because you, as a camera or a light, face a certain direction, you can't see all of the holes. However, if I withdraw you out towards the bottom, you can now see a lot more of the holes and you can shine light through a lot more of the holes. And therefore, you will be able to make more shapes in the room. So I think the only thing that's left to do is wait until all the parts print out, put it all together, and see how it looks. I'll catch you on the flip side. Okay, here she is, the finished product. So it's time to close up the curtains, turn the lights off, and test her out. Turn it on. Yeah. Yeah. Ah. Ah. Okay, so yeah, that failed, and let me just go and talk through exactly what is going on with this dang thing. So first off, we'll start with this corner. On and off switch, honestly, one of the best parts about it, you can flick it on, it's fine. Remote control holder, fits in and out just fine. But now we start to get to the problems. Here is the motor potentiometer. Now the problem is, if it's like this, doesn't turn on, doesn't turn on, doesn't turn on, doesn't turn on. It only turns on until you get around here. But even then, for whatever reason, kind of needs a jump start. I don't understand that part at all. But then we have this spinning gear here, and this has got a few problems of its own. Number one, it's too dang fast. The problem with this motor is that it is a high-speed, low-torque motor. It is made to spin very, very quickly, but it's not made to spin very powerfully. So what happens is, even if it's meshed up, it generally doesn't have the power to properly move it along. And if it does, it's going so fast, it tends to just skim off these tiny teeth. Now, the reason I made these teeth so dang tiny is because I'm trying to fix the fact that it's such high speed, low torque. One thing you can do is to have a high-speed, low-torque motor on a small gear attached to a large gear. So that way it imparts a low speed but high torque to the large gear. Now, in order to maximize the gear ratio, the teeth should be as small as possible. So that's what I tried, and well, it's about impossible to make it mesh up correctly. Again, I don't know why or how I managed to make the hole so dang big. I just straight up didn't do it right. I don't know why. And then we go to the wire itself. I never got anything to insulate these wires, which at best can cause a short circuit and failure inside. At worst, it can start a fire. And then the middle here, you can see, this is fine. This is completely sunken in because if we take it out, great, I just accidentally yanked the wire right out of the receptacle here. God dang it. So this should be pretty self-evident. I had a hard time gluing this all together. Now, the thing about 3D printing is, while it is accurate, it's not hyper accurate. After all, it is a machine just squishing plastic into space. So when you try to make something in which the edges all line up to make a very specific, precise part, it's not going to line up. Like, this isn't even a circle. I had to cut out pieces of it in order for this piece to fit on properly. And my idea was to slice this up so that I could get the actual pre-soldered pieces in there. The fact that I'm cutting through a precise hole like this introduces a lot more room for error if the parts don't line up perfectly. So I think a better way to do it would be to thread the wire through and then solder them like this and then insert them back in. And finally, in my haste, I just kind of printed this crappily, which in the grand scheme of things isn't that huge of a problem, but it's still something I want to fix. So yeah, I stayed up till past midnight last night trying to get everything to match up and all the gears to mesh and everything to work for it ultimately to blow up in my face. So yeah, sometimes you try out something new and your own inability to understand what's going on ends up causing you to fail. And sometimes you just kind of need to leave it there. But this time is not one of those times, god dang it. Get ready, folks, for a part 3. I am going to get the right parts, print a better box, put it all together, get the proper voltages, and I'm going to find an easier way to make more of these globes so I can actually swap them out like I originally intended. So you know what? Social media, you know what to do. See you next week. Bye.